Now we want to use the Pythagorean theorem to find the lengths of the missing sides of the triangles to the nearest tenth of a unit. So we have the same triangle actually that we had in example 2. So it's already labeled for us. We have PQR. Here's our little q, a little r, and a little p. And we have measurements for r and p, but we don't have anything for q. So let's figure this one out. So we know that, again, Pythagorean theorem is a squared plus b squared equals c squared. Well, c is the hypotenuse. Here, q is my hypotenuse again. So this is q squared. So it's equal to the sum of r squared plus p squared. That's q squared. Okay, so r is 3.8 squared plus p is 5.2 squared, and that equals q squared. And just note, it doesn't matter which one of these you put where. It can be 5.2 squared plus 3.8 squared. You're going to get the same answer because you're just adding two things. So 3.8 squared, let's get our calculator. So that's 3.8. You can hit a squared button or times 3.8 because squared just means times itself. And here we get 14.44. And then 5.2 squared, that's 27.04. And that equals q squared. Now we're just going to add those two things together. So I've got 14.44 plus 27.04, and that gives me 41.48. So 41.48 is equal to q squared. Now the problem is I want to know q, I don't want to know q squared. Now how do you undo a square? Well, a square is saying something times itself, so to undo it we take the square root, which means what two things do we multiply together to get a number? So the last step in any question using the Pythagorean theorem will always be to take the square root. Okay, so this is q, and it equals, well, the square root of that. Now, depending on your calculator, will depend on the order. So some of you might have to put in 41.48 and then hit the square root button. I am going to need to find the square root button, which is right here. So if you happen to have a TI, it's a square root. But on another some calculators will do that, and it'll have a bracket. And then I put in 41.48, enter, and it's 6.4404, etc. Now here, these are to one decimal place, so let's round this to one decimal place. So 6.4, I look, the next number is a 4, so that means round down. So it's going to be 6.4, and my units are meters. So there is my